Man, that was fun.
Yeah, it sure was.
So, what do you want to do now?
Well, how about we compare diesel and gasoline by modeling combustion in ANSYS?
Okay, I guess, but where do we even start with this?
Well, first thing is, we need a geometry. With this geometry, we can simulate a combustion chamber.
That's amazing. What do we do now?
Well, I'm glad you asked. After this meshed file is imported into Fluent, we can start to set up the parameters needed to calculate an effective simulation.
That sounds hard.
It really isn't. I'll show you.
What is that?
This is a list of incompressible Navier-Stokes equations that ANSYS uses to solve pressure-based simulations, which is the first parameter that we will check.
Oh, tell me more.
Okay. For time, we should choose a steady solver.
Why is that?
Well, a steady solver runs for a specified number of iterations, whereas the other option, transient, runs until it reaches a solution. The result being it takes longer to reach convergence.
That makes sense, I suppose.
Great. It would be a good idea to also turn on the energy equation, which is shown here, because it will be tracking temperature. Also, because this flow is very turbulent, we will check K epsilon and keep all the default settings.
Cool. What's next?
For this simulation, to model the combustion itself, we will be using species transport.
Why species transport?
This model already has gas-air and diesel-air mixtures pre-done, which simplifies things a bit.
Okay.
Now we need to set up our boundary conditions. Here's where the fuel will be entering our combustor. It will also be set to 80 meters per second, because it's being injected. This will be simulating the nozzle into the combustor, and will be treated as a wall condition with a constant thermal condition of 300 Kelvin. Here's where the air will be entering. It will be moving much slower in relation to fuel, and will be set up to 0.5 meters per second. This will be representing the exit of the combustor.
Alright, I'm starting to understand how this works together.
That's awesome. Now we need to pick a scheme. For this, I think picking coupled and pseudo-transient will be a good idea.
Why coupled and pseudo-transient?
Well, coupled helps with convergence when the mesh is poor, and pseudo-transient adds in pressure terms, which also helps with convergence.
Science is so much fun. I'm so glad I decided not to go to U of M.
Me too. Anyway, all that's left now is to iterate and calculate.
Awesome. I want to see the results.
As you can see, the temp simulations look similar, but the diesel burns just a bit hotter. This shows the mass concentrations of both gasoline and diesel. 5 kilowatts, the diesel uses significantly less fuel. Therefore, it burns more efficiently. This shows the concentration of CO2 produced. Gas produces much more per volume than diesel does. This is why Europe prefers diesel over gas. CO2 is very harmful to our atmosphere, and if the diesel simulation was 100% accurate, no CO2 would have been produced. Another interesting side note, diesel produces much more nitrous oxide, which is very harmful to humans. So, to summarize, diesel burns hotter, uses less fuel, but is harmful to humans, whereas gasoline burns cooler, uses more fuel, but is horrible for the environment.
That was so cool. Thank you so much for sharing this with me. I feel so much more informed.
I'm glad I could help.
Want to fight again?
Sure.